All right, this is chapter 1.2. This is problem 4. And it says graph the following independent functions. This is essentially just like problem 3. We just ramped it up a little bit. Okay, we just got more to it. So this, we have a squared. So that means this one is quadratic. So the first thing we're going to do is plot points for our quadratic function. And I'm going to plot a few on this one. I'm going to do -3, -2, -1, 0, 1, 2, 3. Okay? And now, you don't necessarily have to do this many on your homework, but I do want for your parent functions, I want the 0, 0, and I want at least 2 on either side. Alright? The 3 is a little more complete because it gets you all the way up to the edge of the graph, but that would be 2 on either side is fine. But an x squared. Alright, so if I plug in -3 for x squared, -3 squared is +9. -2 squared is 4. -1 squared is 1. 0 squared is still, well, 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. My wife is trying to trip me over here. She says 3 squared is 12. We can all laugh at her and tell her she is wrong. No. Alright, so let's plot those real quick. -3, +9. So I'm going to go up to the 10, count back 1, and that's +9. Alright. -2, +4, 1, 2, 3, 4. -1, 1. 0, 0. +1, 1. +2, 3. +2, 4, I'm sorry. And +3, 9. Remember, this is a parabola, so we kind of need to give it that nice little curve towards the bottom, at least as best as we can. And we can kind of... I mean, it kind of looks like a V the way I'm drawing it, but it's technically not. I'm better on my left side than the right. Not quite so well. Anyways, so that's the parent function. The best we can draw it, at least. The best I can draw it. Some of you are true artists, and you can draw it el perfect. Alright, here we go. And that was a horrible French accent, but we're going to go with it. X and Y. So let's make our new points. Remember, inside the parentheses is X, and backwards. So inside X, backwards. Outside Y, normal. Inside X, backwards, and outside Y, normal. So, inside the parentheses, literally inside the parentheses, we are going to subtract 5. No, we are going to add 5 to all of our X values. So, -3 plus 5. I took this -3. If I add 5, it becomes +2. -2 plus 5 is a 3. -1 plus 5 is a 4. 0 plus 5 is 5. 1 plus 5 is 6. 2 plus 5 is 7. 3 plus 5 is 8. Hopefully you noticed the pattern really quickly. Alright, the outside's a little more complicated because you got two things going on there. But outside is Y and normal. Outside is Y and normal. So you do it to your Y values and you do exactly what it says. Follow your order of operations and everything. So we are multiplying by 2. Because remember that 2 is multiplying everything in there. And we are going to subtract 8. So, 9 times 2 is 18. Minus 8 is 10. 4 times 2 is 8. Minus 8 is 0. 1 times 2 is 2. Minus 8 is -6. 0 times 2 is 0. Minus 8 is -8. 1 times 2 is 2, minus 8 is -6. 4 times 2 is 8, minus 8 is 0. And 9 times 2 is 18, minus 8 is 10. Right? So here we go. +2, 10. Well, that's +2 all the way up to the top of the graph. 3, 0. Well, that's way down here. 4, -6. 1, 2, 3, 4, 5, 6. 5, -8. Now, rather count all -8. I'm going to start here and just go 2 more down. All right, no sense in counting all those out. 6, negative 6, 7, 0, and 8, 10. All right. And this one is exceptionally difficult for Mr. Hunter to graph, but it looks kind of like that. Oh, come on. There we go. And there we have our parent function. Do that in red. This is our parent function, and this is the one they gave us. Cool. Good luck on the next one.